Good morning, everybody. My name is Alexander Zhimanov. I'm a systems engineer working from Moscow office in Russia. And today we will open the third day of our OSIsoft PI World EMEA 2019 in Gothenburg with a presentation regarding the architecture. And this will be our short agenda that we will try to cover today. We will start with the basics of the PI system architecture. We will discuss how disaster recovery plan will change our architecture. The next topic will be all the factors that affect our PI system. So when we need to grow the PI system, what are the main factors? Then we will see how security considerations affect the different parts of the architecture. And of course, during the last 2 days, you heard a lot about OSIsoft Cloud Services, OCS. We will also make a short brief regarding the architecture between our local PI system, Edge, and also OSIsoft Cloud Services. Okay, let's start from really basics. Imagine you need to create PI system architecture. What are the first steps? Of course, we need to understand what is our data source. It can be an OSIsoft server, it can be a relational database, some kind of text files, SCADA system. Then we need to collect data from our data sources. We are adding the collection node. We can install PI interface there or PI connector. Then, after we collected the data, and maybe added some buffering, we need to send this data to the core part of the PI system, which is the PI server. Of course, it can be, everything can be implemented as a core part, PI data archive, AF server altogether. And then, after we send our data to the central server, we need to send this data to our clients. It can be a PI Vision client, for example. It can be a data link. This is a very simple, very basic PI architecture. We are covering the collection layer, covering the server layer, like a central part, and then we are providing this data to our users. Okay, but what are the factors that affect this architecture? This is very simple, very easy architecture. So how can we expand it? Of course, there are different factors that affect our architecture. One of them is adding our PI system into disaster recovery plan. What is the disaster recovery? Disaster recovery is a set of tools, policies, and techniques that are implemented in your organization to provide the set of rules, in case of unexpected disruption of servers, IT environment, or some kind of data disruption, for example. So what are the main questions that we need to cover during creation of this plan? First of all, we need to understand what is our area where we want to implement this disaster recovery plan. Is it one site? Is it one plant? Or it's the whole environment that has many sites all over the world, geographically spread company? This is the first part. Then we need to decide what are the current policies of disaster recovery plan in your organization. For example, what is the time that is allocated for recovery? So is it enough to have everything back to normal in 1 minute, 1 hour, 1 day, 1 month? So what are the timelines? Of course, we also need to think about the data restoration requirements. So in case of some kind of disaster, what do we need to recover first? Is it only real-time data, which is snapshot, or also we need to recover all the data during the gap? Very important topic in current policy is the time of simulation. So if you are creating the disaster recovery plan, it makes no sense to just create this plan. We always need to test it. It should be done annually, twice per year, once per 2 years. So the frequency of recovery simulations is a very important topic. And of course, the documentation. Documentation should be clear for all of the users that are somehow interacting with the system and need to provide specific steps to recover the system. And of course, if we talk about the disaster recovery plan, we usually have the primary and backup location. And once primary location is down, all the connections between the data sources and all of the users, all the consumers of the data, should be retranslated to the secondary location. That is why the network and connectivity questions are becoming really critical. So if we talk about the PI system in case of the disaster recovery plan, what are the main things we need to think about? First of all, if we want to have our PI system inside the disaster recovery plan, we need to ensure the PI system data availability in case of any kind of disaster or emergency. All the techniques, all the mechanisms like PI backups, redundant services, PI system high availability, IF high availability, all of these tools are not the only solution that you need to implement to have the disaster recovery plan for the PI system. They are part of this plan. But of course, there are many other steps that should be documented to make PI system to have PI system inside the disaster recovery plan. So what are the main requirements for the data recovery and how they impact on the architecture? First of all, this is the scope of protection. Data recovery plan will have the primary and secondary location, and of course, the whole environment in primary and the secondary location can be different, but if you want the zero downtime switch between the primary and secondary location, of course, both systems should be equal, should have the same data, and should be highly available. This is the main idea. If you want to have zero downtime while switching between primary location and the secondary location, both systems should be equal, and you need to support both systems in the equal way. The next important point is the time to recover. If we want to have our zero downtime during the emergency switch between the primary location and the secondary location, we need to have all the steps to switch between these two locations should be automatic. So everything should be done without a human. And all the automatic solutions, they are always more expensive. They are, it is pretty hard to support these solutions. That is why sometimes some of the solutions during the switch can be implemented as a manual step, and another part can be implemented as an automatic, in an automatic way. The next important point is the primary versus backup site design. You need to understand that if you want to have two equal high available systems on both sides, on the primary and the backup side, of course it costs us more money. But you will have the zero downtime during the switch between these two systems. But of course, the backup site can be a small Pi system, for example, not a Pi collective. It will be a standalone Pi data archive with AF server on the same machine. It can be also possible. And of course, if we talk about the recovery part, we need to understand that there are two main things. First of all, we are talking about recovering the data. And the second one is that we are talking about recovering the workload of the services. If we talk about the data, it means that regarding your policies, your company policies, you can just recover the data flow. So you will have a gap during the gap of the data during the emergency. But also, if we are using techniques like OPC HD server, or on the data source level, we have availability to have the history recovery. That's all. The whole gap can be also recovered. And one of the solutions, one of the research from the Nevada University says us that every US dollar that we implement into data recovery plan will save us up to $4 in case of emergency. And of course, if we talk about the best practices during the data recovery plan, so these are the main highlights that I want to show you today. So first of all, the high availability option for Pi system services. It is not the direct solution, not the direct disaster recovery plan for the service. Of course, high availability allows us to switch, for example, between two services very fast. But of course, it is not the only solution that you need to implement. The same thing with the data backups. If you are creating the data backups, please ensure that these backups are working. So even if you have seen that the backup has been created, please refresh, so restore it on the test database and ensure that everything is working, and you will be able, in case of emergency, that you will be able to recover the whole system from this backup. It is very important. And of course, data backups are one of the very important parts of the data recovery plan. The documentation. Documentation should be clear for all of the stakeholders, all the users that are part of the manual processes during the disaster recovery plan should be trained, and they should test it. Very important part is to test the data recovery plan. So when you are testing it, for example, it can be annual data recovery simulation. First of all, you are checking your documentation. The second one, you're checking if people who are in charge, they know how to work, what steps should be done. Of course, you are checking also all the services, if all of the emergency technologies are working. And it will help you to proceed from the primary to the backup location in case of real emergency. So, as I said, the simulation is crucially important. Okay, once we created a really basic architecture, it can be changed, right? So we can make it better, make it highly available, and high availability options can be provided on each layer of the data flow coming from the data source to the user. So first step, to make the Pi system more reliable, of course, we can add another interface or connector node and create a failover. Pretty easy, right? And next step, what can be done next? If we have a lot of tags, for example, on the Pi server, maybe we want to have AF server and our Pi data archive on separate machines. Makes sense. Next thing we want to implement is the Pi data archive collective. If we want to have our time series database highly available, we are adding the Pi collective option, high availability option for the Pi data archive. What can be done next? We can implement high availability option on AF server level. Of course, it will include the SQL part, the relational database on top of the AF high availability. And of course, if visualization is becoming critical for the organization, we are implementing high availability on the visualization part, Pi Vision high availability option. Of course, if we are making a lot of calculations, creating event frames, Pi notifications, maybe we also want to separate the services like AF Analytics and also Pi notifications. That also can be done really easy. What I want to highlight here is that all of these options are really easy to implement on the fly. So for example, you can start with the really basic architecture that we have seen before and add this option as soon as one of the services, one of the parts are becoming critically important for the business needs. This is the idea. And of course, if we talk about the high availability options, it's not just about, okay, I just want to have my Pi data archive running in high availability node. There are specific factors that push us to these solutions, to the highly available solutions. And here are the two main factors that we need to talk about. The first one is the data loss option. Of course, nobody wants ever lose any data. And all the users, all the business users, all the users on each level are, this is a critical question for them. And there are different techniques, different technologies that allows us to mitigate these risks. For example, this is the interface buffering, interface or connector failover. We also have the interfaces that allows the history recovery option, for example, OPC HDA interface. And of course, if data source itself has a risk of the data loss, the data source failover can also be implemented. So data loss is what everyone is concerned about, and we need to implement all of these technologies to mitigate this risk. But also, once the Pi system architecture, Pi system infrastructure, real-time data infrastructure is becoming critical for the business, we also starting to think about the data availability. For many users, the real-time series data that Pi Data Archive, for example, is providing, the data availability of this data flow is very important. So that is why there are different technologies that can be implemented on different parts, on different layers of the Pi system. For example, this is the failover of the collection node, Pi interfaces, and also Pi connectors, and the high availability option for AF, for Pi Vision, for data archive, for analytics and notifications. So we are not talking about just implementing the high availability options. What we want to do is we want to have our data available. But how can we measure our data availability? It's pretty easy. We need to answer the specific questions. For example, how long can we afford to be down? For example, you are not reading data for 5 minutes. Is it okay or not? Is there specific parts of the system that are critical? For example, interface is collecting data all the time, but for example, server is down to implement the Windows server updates. Is it possible or not? Users will not be able to read the snapshot data, the archive data. Is it critical enough to implement the high availability? And if we want to measure the availability, we also thinking about the idea of measuring data availability. So there are different categories that we are talking about when we are talking about the availability. It is called from 1 nines to 5 nines, and this is the percentage of the time, the uptime of the service. And for example, the strongest one, the 5 nines, it is working up to 99%, and then 4 nines after the dot. And we can see that the time when the service can be unavailable is just 5 minutes during the year. But if we implement the category number 1, which is the first row, we can see that the system can be down up to 175 hours per year, which is pretty a lot. This is the data availability ideas while implementing the HA options for different parts of the PI system. And the next topic that I want to talk about are the security considerations. So if we talk about the security, we are always talking about the attacks. So somebody wants to attack our data centers, also want to grab our data and maybe break the service. And if we talk about the directions of this attack, they are always going to the control center. That is why we are implementing the ideas of the firewalls and different different networks. So on this picture, we can see the standard architecture with multiple layers. We have a field network where our plants and also all the equipment is operating. The control center where we have all the SCADA systems. Then instead of going directly from the control center network and the corporate network, we are divided into via DMZ network. We will talk about the DMZ, the demilitarized zone network on the next slide. And of course, all the external connections, so connections coming outside your organization, are also divided by the firewall. And the main idea here is pretty obvious. So we do not want to cross 2 firewalls at a time. So there should be no connections between 3 networks. So one connection, for example, from the user, from the application, from the service, or for example, from the interface, should not ever cross 2 firewalls. It's a very basic idea. So if we want to have our system secure, we want to have all the connections coming only that are coming from the, for example, external network or enterprise network, never directly connected to the control network level. And if we talk about the main patterns that we as OSIsoft recommend to make your PI system as secure as possible, we will discuss right now. So the first pattern is dividing the control network and the corporate network with the DMZ zone, where our PI system is implemented. So for example, you can see all the connections coming from control network. They are not able to cross the second firewall. So interface will not be able to connect directly to corporate domain. So all the connections, all the data flow is going from the interface in the control network to PI data archive and AF server inside the DMZ. So in this pattern, we have our PI system with a DMZ zone. And of course, firewalls are constructed in the way that all the connections are blocked coming from the control network to the corporate network. The next pattern is to enhance, to expand this architecture with a high availability option. So instead of having simple standalone PI data archive, we are implementing the high availability option of the PI data archive directly inside the DMZ. And these are the standard ports that we are connecting through AF and PI connections to the PI data archive and AF server. Another option that can be implemented inside the network of your corporation is the DMZ with PI to PI. What do we have here? If users from the control network also wants to have all their data inside their network, we are dividing the PI data archive into two parts. So we have two standalone systems. This is a recommended architecture that is used by our customers in oil and gas industry. So most of our oil and gas industry companies, our customers, they are using the two PI data archives. So they have one inside the control network and another one in the corporate domain. And the connection between two of these systems is the PI to PI interface that is installed inside the DMZ. So, for example, if attack will be coming from the external network, and the attacker will be able to read the data from or change the data on the corporate domain level. Even in this way, he will also need to cross two firewalls to change some data on the control network. And of course, you can restore all the data coming from the control network part of the PI system. And the next pattern is the DMZ with the PI system connector. So the difference between previous pattern is that instead of having the PI to PI interface, we are installing the PI system connector with a relay. And the enhancement in this way is that PI system connector relay is working under different port. So we are using even different data traffic, and the protocols are disjoint in this kind of architecture. So between this firewall, we are going through the port 5671, and then we are sending this data through the standard ports 5450 and 5457. And if we want to make our system as secure as possible, this is one of the recommended solutions. There are different ways when we are enforcing the security by physics. Everything that you heard about data diode, it also can be implemented here. So if we want to, on the physical level, to block all the connections going back to control network, this is also can be implemented. Once we moved from the PI interfaces to PI connectors, we also invented the new part of the PI system, which is PI connector relay. And this is the same idea. We want to have all the connections coming from only between one firewall. And that is why we can install all the connectors on the control network. Then we are implementing PI connector relay in the DMZ zone. And then, once we collected all the data, we are pushing this data to the PI system that is implemented inside the corporate network. So it's like a mid-level connector node that allows us to make it as secure as possible, because on the level of sending data between the connector and PI connector relay, we're also using the encryption with the certificates. And this is the idea of collection the data in the future. So basically what you need to have is, if you have a geographical spread company with multiple sites and the headquarters site, this is the recommended solution. So on each level, on each site, we do have our local PI system. We are installing the PI system connectors that allows us to send AF data and PI data archive data in the real time. Then we are dividing the plant network and the corporate network with the DMZ zone, of course. And inside the DMZ zone, we are implementing the PI connector relay. And all the connections between the plant network and the DMZ are also, like all the data, is encrypted by the certification. That are the main ideas regarding the network considerations. And the last part that I want to cover is the OSIsoft Cloud Services architecture. I think you heard really a lot during the last 2 days about this new product. And I will show really basic architecture that allows us to send our data from local PI system to OSIsoft Cloud. So idea is very, very easy. Instead of having some kind of PI to PI interface or PI system connector, we have the tool that is called PI to OSIsoft Cloud Services Agent. It is we can install it locally on the site level, and it will send all the data that is necessary to OSIsoft Cloud Services account. So you are once you are registering in OCS, you are receiving the specific area. It is called namespace, and afterwards, PI to OCS agent is sending the data directly to OCS, OSIsoft Cloud Services. So when we talk about one plant, it's pretty easy. So we have on-premise PI system. We are installing the agent, and agent is sending data to OSCS. And for example, as a pilot project. And once the pilot project is successful, we can also implement it onto various plants and various sites all over the world. It's pretty easy, right? So what are the main outcomes from this presentation? What I want to highlight is that there is no perfect architecture. It really depends on all of the inputs that you are creating in your organization. Once the system is becoming more critical, and once, for example, the event frames or identifications are becoming critical for the business, that is the right point to expand. And of course, a PI system is very easy to expand on the fly. It's very easy. So you need to implement HA on one of the layers, just go for it. You will not need to disrupt or recreate the whole architecture. Just add a new node, install the software, create the high availability option. That's it. Everything will be working. And of course, when you are planning the architecture, you need to take into consideration a lot of things, or at least the things that we already covered: disaster recovery plan, security options, the network connection, and of course, if you have any questions, you can always discuss it with our tech advisors or systems engineers. We are here to help you with any questions that you have regarding the architecture. Thank you very much for your attention. Are there any questions? Please wait for the microphone.
Yeah, good morning. Thank you for the presentation. My name is Raed from Saudi Aramco. My question, I have two questions actually.
Okay.
Regarding the data diodes, now there are many vendors now providing data diode that support OSIsoft PI. Is there any kind of certification program from OSIsoft that says, yes, this vendor meets our standard and can do implement the functionality per your expectation? Because I'm sure they are not all created equal. And just my second question quickly is about the cloud services. Can it be used to exchange data between two sites in real time? Because I know, I mean, the purpose now is you push the data there, then your partner can use it to do some analytics. But if I want to do real-time data exchange from site A to site B over this cloud, does it support this thing? Thank you.
Thank you for the questions. So question number one regarding the certification of data diodes providers. We do not have it yet. We have like a best practices, and what we can provide to you is the set of rules that the data provider, like data diode provider, should be able to cover. But for now, we do not have like a specific list of vendors from the data diodes. And regarding the second question, if you want to exchange the data in the real time between the different sites, for example, site and headquarters or different site itself, it can be done through OSIsoft cloud services. What we need to take into consideration is maybe what is the amount of data and what is the frequency of the data, and we can also discuss the architecture, for example, with the PI system connector.
Are you aware now of any limitation? Is there already numbers that you would say it's not good to go beyond, or does it need to be investigated more?
We will do the investigation, yeah. Right. We just need to discuss it together. Okay. Sure. Any other questions? Okay, thank you very much for your attention. The next presentation will start at
10 to, I think.
10.
Yeah.
Thank you very much.
Thank you very much.